So I already did this problem not using the p-value method, just using the traditional method. And I'm going to do the same problem now using the p-value method. Okay, if you want to figure out how I decide that this is kind of a problem that requires the z-test for the mean, just go watch that video. I'll put it in the comments. But this is the z-test for the mean. So this is what we're going to do here. So I highly encourage you to pause the video here and sort of state your hypothesis. And if you know what you're doing, then you should have the same answer as I do. And if not, then just sit tight, watch what I'm doing here, and see whether that makes sense. All right, hopefully you did pause. So my null here is going to be that my mu is 10. Okay, mu is the status quo, is what we are getting without any kind of alteration. My alternative in this case is going to be this business over here. This is the claim here. That's the claim. Okay, that mu is less than 10 minutes. Okay, and that is my claim. Now my alpha is 5%. So this is something that I would need in order to compare my p-value to. Okay. So now I'm looking at this. If I'm doing the p-value, I do not need to do the critical value. I can go straight to the z-test statistic. And the test statistic is going to be here, this 9.25. This is the observed value, minus the 10 minutes, which is the hypothesized value. All right. The population standard deviation is 2 minutes. And I had 35 people in my sample. I put all of this into the calculator, and I end up with negative 2.218. Okay, so I can round that to negative 2.22. Now, I'm interested essentially knowing what would be the probability, because the p-value is the probability value, to get such a value or even more extreme value than that. Okay, so my value here is negative 2.22, and I would like to know what is the probability of getting such a value. Essentially, what is the area under the curve? So probability for z being less than negative 2.22. And this is something that we have to go and look up in our either z table, or you can also use multiple online z calculators. So I'm using here a free online app that you can just go and look up. It's right there from the University of Iowa. And my score here, first of all, I want it to be less than, because I'm looking for a left area, and it's negative 2.22. Right? What's the probability of getting such a value on my z-score? Okay, and the probability is this pink area, which is the area under the curve, which is 0.01. So whoops. Sorry about that, 0.01. Okay, now I need to compare this probability to my alpha. If my p-value going to be less than my alpha, then I have a strong evidence to reject. And in this case, 1% is indeed less than 5%. Then I am going to reject my null. Remember that we are only either rejecting or failing to reject the null. The alternative is just sort of filling in the void, and the alternative is going to come in and stand in place of the null that got rejected. So once I reject the null, I can say that there is sufficient evidence to support the claim. There is sufficient evidence to support the claim. And I want to one more time emphasize that this doesn't mean that the null is false. All this means is that I had a sample, a random sample of individuals, of 35 individuals, and in this random sample of individuals, this claim appears to be a true claim, okay? I have evidence that supports it. This did not happen by chance, okay? But don't forget about this, that this is a random sample, and you cannot tell whether the null is true or false unless you have taken all the adults and given all the adults this stomach calm product. And until then, we don't know. We are going to rely on the evidence that we had at hand. All right, see you in the next one.